Good morning, class. It is Thursday, April 23rd. Before I begin the lecture, I just want to let you know that Lab 8 is now available. It is due this coming Tuesday around 5 p.m. It shouldn't take you long because the way you're going to do Lab number 8 will be based on how we do the problems in today's lecture. So today's lecture, we're going to be using technology, really our calculators, to quickly get the test statistic and the p-value of the problem, where all you have to do is just tell the calculator what your data is, and it will do the calculations for you very quickly. It's great. It's easy, and it will be very quick. So I want you to do, there's two problems on the lab. I want you to do them just like the way we do it today. Okay? So let's begin hypothesis testing part 2 for one sample of data. So again, the goal here is to use the calculator to do the work, to get the test statistic instead of using a formula, and also to get the p-value instead of using another function on the calculator that, sometimes you can make mistakes with it. And we'll be finding these values for our hypothesis test very quickly. And secondly, is to use the calculator to compute the confidence interval to assess our status quo. Remember, the status quo is the null hypothesis value. We've calculated confidence intervals before, but we did those by hand. So again, the calculator will do the interval for you very quickly. And also, sometimes the formulas that we use for these things, they're a little messy, and you can make mistakes with those. So with the calculator, it should make everything so much easier and faster. So I would like to go over something regarding confidence intervals. So previously, we used confidence intervals to estimate the true population parameter, that the true average is somewhere between this number and that number with 95% confidence or 90% confidence, whatever the number is. So for example, let's suppose that a population mean is estimated by this interval, 14 up to 16.2, with 95% confidence. So remember, what was our conclusion on that? We said that, well, we're 95% confident that the true average is somewhere in the interval, or that the interval contains that true value. Okay? But we're not going to be using confidence intervals in that sense. Confidence intervals are used in another way in statistics. So in hypothesis testing, the approach is similar, but the way you word it is different. So the conclusion is written differently based on your null hypothesis or what your status quo is. Okay? Because remember, the interval is used to capture that value. So if your status quo is captured by the interval, you make one conclusion. But if your status quo is not captured by the interval, the conclusion changes. So for example, suppose that our null value or our null hypothesis is mu equals 15. So that means the population average is 15. So that's the status quo. That's what is believed to be true. So let's say that the 95% confidence interval that we computed was the same thing here, 14 up to 16.2. Well, this interval captures the 15 because 15 is in between 14 and 16.2. So what do you conclude when your status quo hits the target? All right, so think of the mu equals 15 as a dart. Think of this as a target. When it hits the target, you don't reject it. It's a winner, okay? So we would say that mu equals 15 is in the interval, so therefore we're not going to reject the status quo. So we do not reject the null hypothesis. All right, so in general, and I believe this is the first question on your NTS for today, all right, relating confidence intervals with hypothesis testing and the decisions that you make in hypothesis testing. So first, if the value of the null hypothesis, which is your status quo, if it's in the confidence interval, it's a winner. So you do not reject the null hypothesis. The status quo is still the status quo. The opposite, well, if the number does not happen to be captured by the interval, then that number is no longer the status quo and you reject it. So you would reject the null hypothesis if your value is not in the confidence interval. So notice now that these are the decisions I really want you to focus on, not the decisions where you say, oh, we're 95% confident that da-da-da-da-da. All right, so we're using a different approach with the confidence interval, and this is the approach that I want you to take, on the lab especially. All right, so again, you can always think of it as a dart versus its target. So the null value is the dart, the confidence interval is the target. If it hits it, it's a winner, you should not reject it. But if it misses the target, it's a loser and you reject it. Okay, so again, our focus today is to use the calculator to come up with the final numbers that help us make decisions about our hypothesis test. So using the calculator, we're going to press Stat, and then we're going to scroll over to this third column here, the test menu, and there's all sorts of tests in there. Okay, so far we have done a test for proportions of one sample and averages of one sample. So for proportions, here's what you're going to be using. So notice with number 5, it's one prop z-test. So 1 means how many samples you have, so there's one sample, and prop means proportion, and we always use a z-test for that. Now if you take a look for the confidence interval for that, at A, it's a very similar name. It's 1 prop z int for interval. Okay, so you're going to notice that from the top of the list, from number 1, so from number 1 to number 6, it's test, 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 test. So these test programs are going to compute the test statistic and the p-value for you. And then if you notice, if you go past number 8, it's int, 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 int. So these are all different types of confidence intervals. All right, and then there's other tests after that, but you don't need to know those. All right, now for means. So now remember, when we're testing a mean, either sigma has to be known or it has to be unknown. When it's unknown, we're using t-tests. So if you take a look at number 2 and number 8, so number 8 is the t-interval, and number 2 is the t-test. So that's one sample tests when you're using the t-distribution for testing a mean or an average. Okay, so these are the only ones you need to know right now. Next week, we'll look at a couple of others when we're doing 2 samples. So notice there's a 2-samp in some of these. Okay. So these are the programs that you need for proportions and programs that you need for tests. One final note, for the mean test, if sigma is known, then instead of using 2 and 8, you're going to use 1 and 7, the z-test and the z-interval. Okay, so also don't forget the p-value approach, which is actually the approach we will use using our technology. It's a much faster and convenient approach to hypothesis testing is the p-value approach. So remember that we reject the null hypothesis whenever your p-value is less than alpha. And alpha, remember, is the amount of error, or type 1 error. Okay? So if your p-value is less than alpha, you reject the null. Otherwise, no rejection. All right, so now here we are at example 1. So in example 1, we're going to be using proportion test to run our hypothesis test here. So I'm going to read through it. A 2009 study found that 34% of teenagers text while driving. Shame, shame, shame. A researcher claims that the proportion has changed since then. The researcher conducted a new study which found that 353 of 1,200 randomly selected teens had texted while driving. Use alpha equals 0.05 as the level of significance to test the researcher's claim, and also use a 95% confidence interval to assess the results. Okay, so let's hit stat and tests. And remember, this is a proportion test. So this is where you have to now think about which number do I use here? Do I use 2 or do I use 5? I'm going to use 5 because this is clearly percentages and proportions being measured here. So we click on 5. Now look at what it requires. It wants to know what's the value of the null or your status quo. Well, that was 0.34. So you type that in. And then we have x and n here. N is the number of people in your sample, which is 1,200. And then x is that smaller number out of the 1,200, which are these teens who were texting while driving. So those 353 get placed there. Then you have to tell the calculator what your alternative hypothesis is. Is it not equals, is it less, or is it greater? So before we finish that, let's add some things here. Let's look at our hypotheses so we can choose the correct symbol. So the null hypothesis is the status quo, right? That our percentage is 34%. And The researcher wants to know if the proportion has changed since then. Well, they don't say that it's gotten larger or gotten smaller, just that it's changed. So remember, that's when you use the two-tailed test. So what we're going to do is, now in my menu here, I'm going to choose the not equal to symbol. And you have to choose the right symbol because you're going to get different p-values for each of them. Okay? So make sure you choose the right one so you get the correct p-value. Color doesn't matter. Hit calculate and not draw. Okay, so now, what's the p-value here? All right, well, take a look at the one that says p, not p-hat. P-hat is just the 353 over 1200. That's that percentage. What you want is regular p. This is the p-value. It's not 8. All right, take a look at this. Remember, E-4 is scientific notation, which tells you to move your decimal point 4 places to the left. So it's really 0.0008. So there's your p-value. Now, what's the conclusion now? The test conclusion here is that we reject the null hypothesis because the p-value is less than alpha. And make sure you state that full statement there. Don't just write down reject. Write the sentence that you reject the null hypothesis since or because, you have to justify why you're rejecting, all right, that your p-value is less than alpha. Okay? Now, here's the new part, using the 95% confidence interval to assess the results. Before we do that, let me back up a step. The interpretation of this. So you know how I asked for a sensible conclusion? This is this part here. What's the sensible conclusion here? We are rejecting the null hypothesis, which means we are using our evidence to essentially support the alternative hypothesis, that the percentage of teens who text while driving has changed. So, all right, so that's what you would say, is that there is sufficient evidence that the proportion of teens who text while driving has changed since 2009, and thus may no longer be 34%. Okay? All right, so now the confidence interval. So let's run the program for that. So if you do stat and tests, and remember it's A, so you scroll down to A, 1 prop Z interval. Now here's the nice thing about program 5 and program A. They're really for the same thing, 1 proportion, Z test, and Z interval. So when you enter data into one of them, it automatically carries over to this one, except the confidence level. So notice the X and the N were the ones that we used. Change the confidence level. That's 90%. That's wrong. So 0.95 would be the correct confidence level. And right there you go. There's your confidence interval in the parentheses at the top. All you need are these two numbers at the top. So there's your confidence interval. Now, don't just copy the interval and move on as if that's the end. Now you have to interpret it. So remember here with confidence intervals, you have to compare your null value to this interval. This value of 0.34 is not contained in between those two numbers. It's not contained in the interval. So just like the last part of the test, we're rejecting the null hypothesis. And those two parts should usually agree. The p-value part and the confidence interval part usually agree almost all the time. All right, so now how do you interpret your interval in the context of the problem? Well, the interval is trying to estimate the true percentage of teens who text while driving. So notice that the percentage estimate here is less than the status quo, right? Status quo is 34%. The interval is estimating about 27% to 32% of teens are texting while driving. So the interval estimate or estimates that the new proportion of teens who text while driving could be less than 34%, okay? And notice my language with the word could. We never say that, oh, that's the truth, that's a fact. We always say that it could be or it might be because we have 95% confidence but also 5% error. So you have to use words that also allow for your statement to be wrong but not in a bad way. Okay? Let's go to example 2 now. So here we have a data set where we're going to have to enter the numbers into the calculator. So we have here that the mean time waiting in line at the drive-thru of a fast food restaurant once the order is received is believed to be 84.3 seconds. A customer claims that the wait time is longer than advertised. A sample of wait times in seconds is shown below. Test this claim that the customer makes at alpha equals 0.010 and with a confidence interval. Okay? All right, so what you need to do is first tell the calculator in a list by hitting stat and edit what those numbers are. So here are the numbers. All right, now what are we going to do here? Well, first thing maybe we should do is write down what the hypotheses are, right? So the status quo is what the restaurant is claiming, so that the mean wait time in line is 84.3 seconds. So use mu, not p. This is a mean. Now the customer is claiming that the wait time is longer, so of course greater than would be the alternative symbol. And that makes it a right-sided test or a right-tailed test. So we go to stat and tests. We're going to choose now, remember number 2 is the t-test for averages. Now here's something different about this program than with the proportion program. With the proportion program, there's only one way to enter data. With problems like this, there's 2 ways to enter data. All right. Now notice in this menu here, the stats menu, it needs the null value, x bar, s, and n, and the inequality symbol. But we don't have all that information. So now watch this. Click data. And notice now you have an alternative way to enter the data through a list. All right, now the null value is not 0. Change that to 84.3. Make sure your list number is the correct list number. Mine's list 1, so I don't need to change that. Frequency should not be blank. Just put a 1 there. Don't worry about what that means. Just select it. And then we need the greater than symbol, so y, so we get the correct p-value. So we use the greater than symbol. Don't worry about the color. Don't click draw. Click calculate. And there we go. So we have our t, that's our test statistic, negative 1.3. If you use the formula that we used last time, that's your test statistic. And here's your p-value, 0.8888. All right. So the p-value is 0.8887. Now, what do we conclude? This p-value is much bigger than the alpha value of 0.10. So that means we are not rejecting the null hypothesis. The status quo is the status quo still. All right, and that's again because that the p-value is more than 0.10. So now let's interpret that. So since we're not rejecting the null, we are using our evidence to, in a sense, support this status quo. So we would say that the mean wait time could still be what's advertised, 84.3 seconds. However, for this customer, we would have to tell them, sorry, we do not have sufficient evidence to support your claim that the wait time is longer. All right, how about our confidence interval now? Now here's a question. I didn't tell you which confidence level to use, but could you guess it? All right, alpha is your error, right? If we're using 10% error, how much confidence should we be using? 90, all right, because 90 and 10 is 100%. All right, so now to do this, you're going to click Tests again, and we need number 8, the t interval. And notice this is already set up for the most part and with the way I entered it in the previous program. So I have data, list 1, frequency is 1, but the confidence level, make sure you look at it, needs to be 0.90. And it drops off to 0, that's okay. Hit calculate, and there's your interval right at the top. You don't need the other stuff. So first copy your interval, and then you have to tell me something about it. All right? Now remember, what are we supposed to compare here? The null value. 84.3 is between these two numbers. It's in the interval. So it's hitting the target, so we do not reject it. So therefore, the null value is in the interval. We do not reject the null hypothesis. Okay? And the conclusion is the same here. You don't need to rewrite the interpretation because we ended up with the same conclusion. There's nothing different to say. There's nothing else. Example 3, testing a mean with stats given. So this time we're going to be using program 2 again, but this time we're going to be using the other method of inputting data. So in the last example, we used inputting data through a list to run the program. So this time we're going to input the statistics that are already known from your data set. So let's take a look at the problem here. So according to the American Time Use Survey, a typical American spends 154.8 minutes per day watching TV. A researcher believes that this is an overestimate. A survey of 50 Americans results in a mean time of 128.7 minutes per day with a standard deviation of 46.5 minutes. Use alpha equals 0.01. Now this is a very short sentence here at the end, and most problems in statistics like these usually have a very short phrase like that. The last two examples, I gave you a phrase that was a little bit longer. This way you could really understand as to what does that mean, use alpha equals 0.01. So remember that that is your level of error or significance, okay? And this is the number that you're going to need to compare your p-value to. And also, this is your error value. So if you have 1% error, we know that when we do the confidence interval, the interval is going to have 99% confidence. Okay, so let's start with the null hypothesis, right? The 154.8 is believed to be the status quo. Now, the researcher believes that this is an overestimate. So what is that saying? It's saying that this researcher thinks that the number is actually less, right? That the actual value is less. So the alternative hypothesis is that the true mean is less than what is stated, that this 154.8 is too high. Okay, so now that's a left-tailed test because of the less than sign. Now let's see what we can do here with our calculator to input these values. So the null value there is the 154.8, so we're going to enter that. X bar and S, that's the mean and standard deviation of the survey. So that would be the 128.7. And S is 46.5. N was 50 people. And then we're going to choose the less than sign for the inequality. Then we choose calculate, and bam, we're all set. So the p-value there we can see is 0.00012. Remember, the p-value isn't 1.1. All right, there's an e-4 at the end of that. You have to move your decimal 4 places to the left. So the correct value is 0.0001 or 00012, whatever you like. So that number is less than alpha. So therefore, we're going to conclude that we reject the null hypothesis since the p-value is less than alpha. So what does that mean? We are rejecting HO. We are rejecting the status quo here. So that means we have evidence to support this, which was the researcher's claim. All right? So there's sufficient evidence to support that the mean time could actually be less than 154.8 minutes per day. You could also say that there's enough evidence to say that the status quo could be an overestimate. Let's get the confidence interval. So now we're using stat and tests, number 8, the t-interval. Okay, and did everything update here? It needs X bar, it needs S, it needs N. My interval confidence level is wrong. It should be 0.99. Hit calculate. Bam, there's your interval. And remember, that's a 99% confidence interval for the mean. Okay. So the true mean is somewhere between 111 and 146-ish. Now, what does that mean? Look at the null value. 154.8 is not in this interval. So that means, again, we reject the null hypothesis. And now, based on the interval, we could say then, all right, well, if the null hypothesis is rejected, the interval is actually estimating, just like our conclusion here, that the time spent watching TV could be less than 154.8 minutes, because all the numbers in this interval is less than the status quo. Okay? Okay, and that is it for your NTS and the problems for today. Let me just mention something about Lab 8 before you log off here. So you're going to complete Lab 8 in the same manner as today's problems. Okay, so I would like to see that you've used the calculator for this, not the formulas from Tuesday. Okay? And of course, Lab 8 will be uploaded into the Lab 8 folder, and you have till Tuesday at 5 o'clock to do that. And today's NTS in the usual spot, and that's it. Have a great weekend.